So in this lesson, we're going to continue with our 4 footprints and we're going to extrude them so they have some mass. And then we're going to divide the facades into an equally spaced grid because we're going to use that grid to emit our view rays. So I'm going to continue again with the previous definition we left off in previous lesson. And let's start on a new line. So let me insert a curve component. Connect it to our 4 footprints and drag it to more or less here. And let me set the wire to hidden. Nice. So I want the facade to be individual surfaces. So before we extrude our 4 polyline curves, we're going to explode them first using the explode command. So we have individual line pieces. And we're going to extrude them using the extrude command. Let me insert a unit C. And let's say we want them to be 50 meters high. So let me go to perspective. So we see what's going on. So now we have 4 paths, and within those 4 paths we have the individual surfaces, or our facades, that represent our facades. And before we start using the divide surface component to populate the surface with points, we need to shrink those surfaces a little bit. That is for the reason that if we're going to emit the rays, the points that are all the way on the edge, sometimes they don't intersect with the surroundings. Let me turn on the context to show you that. If I go to front view, you see that our context lines up perfectly with the 0, 0. But sometimes a ray can slip underneath. That's why we're going to rescale these facades a little bit, or those surfaces. Like with a couple of centimeters. And for that we first need to insert the deconstruct domain component located under the math tab, under domain and deconstruct domain. And we also need to insert the construct domain again, because after that we're going to construct a new domain, a little bit smaller. So we need to add some addition and subtraction components and a small slider. So let's rescale them with 5 centimeters. I think that's more than enough. Or even 1 centimeter, I think can be small. So let me connect the addition to the U0. And connect the slider to it also. And subtraction to that again. So what we did is that we add a small amount to the U0, which is one side of the domain of the U direction. And the U1 is the upper limit of the domain. And we subtract like the 1 centimeter from that again. And then we connect it back again to the construct domain. And we need to do the same for the V. Like this, and reconnect it again to construct domain. So let me insert a panel to show you quickly what happened. To show the domain, we need to insert a domain component. So we can preview the domain of the surface. So the bottom one, as you can see, it's from, the U is from 0 to 50, and the V is from 0 to 19.04, etc. And the top one, that's a rescale domain. And as you can see, instead of going from 0 to 50, it goes from 0.01 to 49.99. That's because we subtracted and added the 1 centimeter. So now if we insert a component called, let me see, it's under surface, then utility, and it's called isotrim. Connect original surfaces. And also let's connect our reconstructed domains. And now if we zoom in Rhino, you see that they're offset a little bit from the original ones. And this will prevent the view rays from going underneath the buildings. So it's a slight trick. So let's continue by dividing our surface into our equally spaced grid. And like I mentioned, we're going to use the surface divide component for that. And that component is also located under the surface tab, utility and divide surface. Now we need to find a way how to divide that surface into an equally spaced grid. And if a facade would grow, it would maintain that grid basically. The way we're going to solve that is by first getting the surface dimensions. So if you go to Analysis and insert the Dimensions component, this will retrieve the U and V dimension from a surface. And now if we divide those dimensions with an amount, let's say 5, for 5 meters, which means that we're going to have a grid of approximately 5 by 5, because we're going to also divide the V by that amount. Nice. And by preventing that this amount, the divisions, let's say, of the surface will be smaller than 1, we're going to insert a maximum component and insert 1, which means that this number will never be smaller than 1. If we are going to use a number smaller than 1, the divide surface component will give us an error. Nice. All the facades are more or less equally spaced with a grid of 5 meters. And that depends, because it's going to be rounded off, let's say, if I insert a panel. The numbers will be rounded off. But at least like they're going to be around the 5 meters division mark. I can show that to you by just inserting our own rectangle for now. So I can show it to you a little bit more quickly. So let's insert a curve instead of our 4 plot outlines. So if I scale this curve to be smaller, at some point the amount of divisions get less, because they always want to maintain the grid of 5 by 5 meters, more or less. If we grow a facade, the grid should also grow. And if I make a really small facade, you see that we always have a grid division of 1, even if it's like really small. So that's nice. So let me reconnect our 4 plot outlines again. Now the next step is to emit our view rays from our points we just generated. And for that we're going to use a component called Mesh Ray. And that component is located under the Intersect tab, if I'm not mistaken, and under Mathematical and Mesh Ray. So this component requires us an input geometry, which is a mesh. And those are going to be the surrounding buildings. The P, those are the start points of the ray, and those are the points we just generated. And the D is the vector or the direction, and that's a normal. So the bottom two, we can already insert those, but we need to offset these points a little bit from the original facade, because else they're going to intersect with themselves, with the original building mass. So let's insert a move component. So we're going to move these points and an amplitude vector with this vector, and let's say with 1 centimeter again. So they're just offset a little bit from the facade. Yeah, as you can see here. So they're offset just like a slight bit, because those are going to intersect with themselves, with their own facade. So the points go in the P. The normal goes in the D. Now the only one missing is the mesh. And for that we need to convert our surrounding buildings first to meshes. So let's drag our surrounding 3D context from the beginning. So to convert these B-wraps to a mesh, there's a component called B-wrap mesh. Mesh B-wrap. So now they're all meshes, which is fine. So the next thing, because we also want to include, of course, our 4 buildings for the views. So let's insert a B-wrap. And those come from here, like the ones we just generated. Let me also set the wire to hidden. And we're going to do the same thing. So copy this component over and transform our 4 buildings to meshes, or our 4 facades. Nice. So there's just one thing missing, and that is creating a big circle surrounding this whole scene. Because if a view ray doesn't hit a surrounding building, we want it to be at least somewhere cut off, let's say. So let's generate a big circle using the circle component. And to get its center, we're going to use the bounding box component. And to find its center, we're going to use the original plot outlines. Don't forget to set it to union box. Set this wire also to hidden. Get the area of the box. And now we have the center point. So that's going to be the center point of the circle. And let's set the radius of the circle. Let's a big number. Let's say 800 meters. As you can see in the top view in Rhino, we have a really big circle. If a view ray doesn't hit a surrounding building, at least it's going to hit the circle. And also let's extrude this circle like we did with the 4 plot outlines using the extrude B-wrap component. And let's set this number to 200, like a big number. So it's like a big wall. Nice. So one final thing is to convert this B-wrap or this surface to a mesh. And we can use the same component again for that. Nice. So we have 3 meshes basically, and we need to join them together into one big mesh. And there's a nice component called mesh join. So let's connect them all 3. If you hold your shift key, you can add multiple wires to a single component without disconnecting the previous wire. And don't forget to flatten the input. So now we have one big mesh, basically. And that big mesh goes all the way to the mesh ray component. Nice. So there's just one thing remaining, because the output from the mesh ray gives us the first intersection point. And the H, it's a boolean if it hit or if it missed something. For now, we're not going to use the H. Later on in the course, yes, but for now, we're just going to be concerned with the X, the intersection point. So let's insert a line component. So we're going to draw a line from the original division point, which is this point. And with the intersection point. Because we know that there's no misses, like our mesh rays at least hit one mesh. Because we made sure of that with the circle. So now if I connect them together, you see that I turn on some unused points. You see that they all got their view rays emitted from the facade, which is very nice. And also if I set this number to 0, which means if you wouldn't have offsetted the facade, you see that something goes wrong, because sometimes, I mean, here they got emitted, but here no, they're intersected with themselves. That's why we need to offset them with a very small amount. And the same goes with the shrinking of the surface with a small tolerance. So in the next lesson, we're going to start taking a look into how we're going to define the view quality. And like I mentioned in previous lessons, is that we're basically going to state that the longer we're going to add all those few lines you see in the Rhino canvas, we're going to add them all together for the 4 footprints. And the longer that number is, or the bigger that number is, means the better the view quality. And that's basically a simplification of how to measure the view quality. Of course, you could make it more complicated, but the simplification of, okay, just stating that the longer the lines are, the better the view quality is. I think that's fair enough to state. And also we're going to take a look into dealing with multiple fitness values, because as you can remember, we have the view quality value, which is 1. And then we also have the square meters, because we need to make sure that they're around 1000 square meters. And the third one is the distance between the 4 buildings, because of course we also don't want them to be too close to each other for sunlight falling on the facade and also accessibility. So thank you so much for watching, and I'll see you in the next lesson.